So let us begin with the seventh problem in this series, and the seventh problem is problem number 2.7. A vessel of volume V is evacuated by means of a piston air pump. One piston stroke captures the volume delta V. How many strokes are needed to reduce the pressure in the vessel eta times? The process is assumed to be isothermal and the gas is ideal in nature. So again, let us begin the problem by first of all drawing a diagrammatic situation. So over here we need to understand that this question is based on the operation of an engine. So let us understand what is exactly going on. So in this engine, first piston is pull right side. So over here we have this piston arrangement. Let me mark this as piston. So initially this piston is pulled in the right side, and during this pulling time the valve is opened and the gas is filled in the vacant space. So which is this part. The gas is filled in this vacant space. The valve is then closed and the gas between the valve and the piston is removed. So this is what is exactly going on. So this piston is shifted towards the right. As it shifts towards the right, this valve on the other side is opening up and the gas is filling in this chamber, and then after that the gas is removed. So after this the piston is again pulled right way and valve is opened and the gas comes with piston, and this process technically continues, and this is how this particular pump which is mentioned in this problem is operating. Now it is also mentioned over here that this process is isothermal in nature. This process is isothermal in nature, and hence over here we write for first stroke. For first stroke. So we need to understand what the problem is exactly saying. The problem is saying that a vessel is of volume V and it is evacuated by means of a piston air pump. This is the piston air pump which we have demonstrated over here. So one piston captures the volume delta V. This is the delta V which we are talking about. And then the problem is asking how many strokes are needed to reduce the pressure in the vessel by eta times. So again I am repeating it. The piston is first shifted towards the right, as a result of which the valve on this side opens up. This is the valve which opens up, and the gas is eventually filled into this chamber which is of volume delta V, and then this gas is ejected as the valve closes. Now again the piston will be moved to the left side. Then again as the pulling will be done on the right side, the valve will open, again the gas will fill and then it will be ejected. So this is how the gas removal is being done. So over here we are writing for the first stroke, since the pressure is since the process is isothermal in nature, we say PV is equal to P1 and the volume is increased by delta V. So P plus delta V, and hence over here that we can say that pressure P1 becomes P V upon V plus delta V. So this is the final pressure after the first stroke is conducted. Now we write after the second stroke. After the second stroke. So after the second stroke we say that P2, this will be equal to P V upon V plus delta V, and this will square in value. So similarly we can say that after nth stroke, after nth strokes, after n such strokes, what is going to happen? So we write Pn is equal to P V upon V plus delta V to the power n. So this is the value that we have. Now the problem is suggesting that the P final, or after the some strokes, the value should drop down to eta times the initial value, and therefore we can say that if it is equal to P by eta, then it is equal to V upon V plus delta V to the power n, and we have to determine this value of n that we have. So if we take log on both sides, so over here P is cancelled out and we get 1 by eta. So we can write over here eta as equal to v plus delta v by v to the power n. And over here if we take log on both sides, since we are solving for n, then we write ln eta is equal to n times of ln of v plus delta v by v, and hence the value of n which we are looking for is equal to ln eta upon ln of 1 plus delta v by v. And this is the final answer for this particular problem that we have.